Can you see? Good.
Are we allowed to turn the heater on this one?
Yeah, I asked about getting it fixed yesterday.
Oh, they don't work.
I don't know what's wrong with them. They're not working properly. It's already turned on, you see.
Oh,
The principal said she'll contact the maintenance people, so hopefully it'll be fixed soon then. Okay. A student can either study for less than 25 hours, between 25 and 50 hours, or more than 50 hours. Okay, so the possibilities start off like this. They can study for less than 25. They can study between 25 and 50. And they can study for more than 50. Fine.
this confused me. Isn't that greater than?
This one's less than 25, 25 to 50, and then more than 50. If they study for less than 25 hours, the probability they will fail is 0.8. So this is fail 0.8, and so then pass is 0.2. Yeah, is that right?
Oh, that also.
Huh? Oh, sorry, there's 3 grades, not just fail and pass. It's fail, pass, and merit. Okay, so what's a pass then? 0.1 and 0.1. Like that. And like that then. Fail, pass, and merit. Fail, pass, and merit. Okay. Next one. If they study between 25 and 50, fail is 0.1 and pass is 0.8. So then merit is 0.1 as well. If they study for more than 50, they will fail as 0 and pass is 0.5. So that means merit then is also 0.5. In a school, the number of students that study for more than 50 hours is twice as many as those who study between 25 and 50, which is also twice as many as those who study for 25 hours. So this is where it gets really tough. What I'm saying is the probability someone will study for more than 50 hours is twice as much as 25 to 50, which is also twice as much as 25. So there's a couple of ways to think about it. If you call this probability P, then this one must be 2P, because I told you there's twice as many here than here. And likewise, if this is 2P, this must be 4P, because I said there's twice as many here as here. Therefore, we can get the P, because the total has to be 1. So then the P is 1 over 7. P plus 2P plus 4P has to equal 1. 7P has to equal 1. P is 1 over 7. So the probabilities are 1 over 7, 2 over 7, 4 over 7. Yeah, yeah. And also there are 30 students. Okay. Alright, so the first question is how many will get a merit? So first we should calculate the probability of a merit grade. So there's 3 ways I can get to merit. This part, and then this part, and then this part, and then finally this part and this part. So the probabilities would be 1/7 times 0.1, which is 1/10, plus 2/7 times 1/10, plus 4/7 times a half, or if I want, I'll write it as 5/10. Because then it's easy in my head to do this. This is all over 70, so that's 23 23 over 70. Yeah? I hope. 23 over 70. Yeah. So that doesn't tell me how many students got a merit. So if I know there's 30 students, what should I do next? Oh, come on. Yeah? No. Come on, don't be so sleepy. Yes. Oh, that sounds complicated. How about I just multiply this by 30? Yeah. So this is the number of students. What is that there? If you can type that in, please.
You want fraction?
No, because it's people. Give it to me as a decimal.
9.85.
Okay, so I'm going to say roughly 10 people. Roughly.
You shouldn't. When we're talking about people and it's there's decimal.
Yeah.
Don't we have to run down because it can't be.
It's complicated, and it's not always clear. For this one, I think it'd be more accurate to round up, because you're talking about probabilities, you know? So just ask yourself this question. 9.85 is impossible, right?
Yeah.
Impossible. Can't have 9.85 people getting a merit. So which is more likely, that 9 people will or that 10 people will? 10 people would be more likely, because you're closer to 10 to begin with. So if somebody said to you, make your best estimate for how many people will get a merit, then I would pick 10. Because it'd be more likely to be 10. I mean, think about it. It's not even going to be 9.5 anyways, because these are probabilities, you know? So like maybe one day it turns out to be 6, and the other day it turns out to be 12. It's just you're saying on average it's 9.85. So our best guess is 10. Okay. The next one is how many will get a pass. So the probability of a pass, that would be 1/7 times 1/10 plus 2/7 times 8/10 plus 4/7 times 5/10. 20, 36, 37 over 70, I think. So then the number who get a pass would be 37 over 70 times 30. What does that equal? So we'll say 16. Yeah. 6 over 7. Where's my 6? I don't see a 6. This one's a 4. Yeah. Okay. And the last one, the probability of fail. That is 1/7 times 8/10 plus 2/7 times 1/10. And the last one's actually a 0. That's 10/70ths or 1/7. So the number would be 1/7 times 30. What is that?
4.28.
So 4 then. Which is good because the whole thing adds up to 30. Yeah. Yeah. 96. Maybe it's my mistake, yeah. The answer's 20%, yeah. Okay, let's see, let's recalculate. So 96.9. Yeah? What was your answer, Angela?
0.3.
Oh, so we have 3 different answers. 30%, 15% and 20%. Let's find out which one is right. Maybe none of them. Okay. Okay. Oh, sorry, do you need me to go back? Do you have that?
Yeah.
Yep. Right, 9 on 96. So, Angela, here it's a Venn diagram question. Oh, did I not get it out? Something must have fell out. What happened? Did it come back for a second, or it's been out now for the last minute? Oh, okay. Maybe it's just getting a bit loose. Right, okay. So my two events seem to be brown eyes and male. Okay. The probability of a person in Ireland being born with brown eyes is 70%. So that brown Venn diagram is 0.7. And being male, of course, obviously is 0.5. I don't make it clear in the question, but the only two possibilities for eye colour is brown and green. But I should perhaps have explained that. I need to make a note of that. Yeah. Yeah. I'll fix that later. Anyways, we imagine people only have brown or green eyes, but I know there's more than that. Okay. So I think my trick like before, was that what was causing the problem? No, okay, it wasn't. Right. X here. This is 0.7 minus x, and this is 0.5 minus x, and this here has to, what else do I know? This is all the information I know, isn't it? Yes, yeah. Okay, good, I like it, and this is why. So, this is, yeah, I can see why this is, why I did this. Right, so what can we make here? We can say 0.7 minus x plus 0.5 minus x equals, plus y equals 1. Right, so that and that cancel, yeah? 0.7 plus 0.5 is 1.2 minus x plus y. That should equal 1. So minus x plus y should equal minus 0.2. So x minus y equals 0.2. Okay, so we seem to have a little problem here, because we don't quite have enough to work out the x and the y, do we? Because there's only one equation here. Is there anything else I might know or could use here?
Is
0.7 minus x.
that will be female with brown eyes, and Y is female with green eyes.
Yeah.
So maybe that is 0.5.
You're nearly there, but not quite. Well, you two tried it, so what did you do to get past this bit?
I skipped the Y.
Okay. Yeah?
Your Venn diagram is male with green eyes.
Yeah.
So the center will be X.
Yeah.
And then for the green eyes is 0.3 minus X.
Okay.
And for the male is 0.5 minus X.
Good, okay, fine. And you got an answer?
I took 0.5 times 0.3, and it's 15%.
0.5 times 0.3. Okie dokie. That is correct. That's correct. So the one piece of information which wasn't used here, and I didn't say it in the question because I wanted to see if you could figure it out. You kind of figured it out, and you nearly got it. We think these two events are independent. That one shouldn't affect the other. It doesn't really matter if the person is male or female. It doesn't have any effect on what their eye colour will be. I think that's true, isn't it? Yeah. So, you had one formula you used to make use of that. So do you remember, what do we say if two events are independent? What's the formula? Probability of, in this case, B and M should equal PB and PM. Now that's actually really nice because this here is X. This here you know, what was it, 0.7, and this here you know, 0.5, so that's 0.35. If that's 0.35, then it makes the Y must be equal to 0.15, if you sub that back in there. And my question was, what's the probability a person is born male with green eyes? So that's the probability of not brown and male. So let me look at my Venn diagram. Where is not brown and male? Is that here?
There, 0.5 but that's only on one.
Yeah, is that not my answer at the back?
No, it's just
Okay, I think that's wrong then.
What if they were dependent?
That's a problem then, because I need to give you more information.
Like what if B intersection M does not equal to
Yeah.
B?
Then I need to give you more information. Yeah, no, that's definitely wrong. The answer is 15, not 20. Okay. Did you got 15?
Yeah.
Okay. You didn't.
I didn't use so much.
Yeah, that's okay. That's okay. You had the right idea. Okay, what's next then? Oh wait, just before that, actually, didn't you say 9 and 10? Okay, let's just look at 10 before we go on to that. The problem. Okay, so let's draw this here. The probability of event A is the same as the probability of event B. There's A and there's B, and they have the same probability. The probability of event A is twice as likely. Okay, so I think I need to start putting in letters here. So I'll just put in X, Y, Z for the moment, and maybe W here. The probability of A is the same as the probability of B. Okay? The probability of event A is twice as likely as the probability of A and B. The probability of event B is twice as likely as the probability of event A and B. The probability of A or B is 9 times more than the probability of neither A nor B. Okay, so I just changed all that English into equations here. They're not as bad as they look, because already straight away, what can I cancel here? The y, so I get x equals z. This one here is x plus y equals 2y. So actually, if I took this y to the right, what would I get here? X equals y, 2y minus y. If I took the y to the right here, I get z equals y. Now let's look at what we have here. X is the same as z, x is the same as y, so y is the same as z. So x, y, z are all the same.
Yeah.
So I could change the last guy into something like 3x equals 9w. So then that means x would equal 3w. So w is 1/3 of x. Yeah. So here, this one here is x, 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 and 1/3 x. So what's the total there? 1, 2, 3 and a third. 3 and a third is 10/3 x, and that should equal 1. 1 plus 1 plus 1 plus a third. Yeah? So then what does x equal? X is 3 over 10. So we're finished. This one was 0.3, this one was 0.3, this one was 0.3, and this one is 0.1. Okay? What did you say next, Sabrina, after this? 98, number 11.
Can you do after that one 9410?
9410. What's 9410? Did you try it?
Yeah.
Hang on, wait a sec. You said 98, which one? 98, 13. Okay. 98, which one? 5 and 6. Okay. Let's see. All right. 98, 5. Consider two events A and B. Note that the probability of event A is 0.6. Of A and B is 0.5. So that's 0.5. That one has to be 0.1. And finally, the probability of A given B, which is equal to the probability of A and B over the probability of B, equals 0.625. So that means the probability of B is equal to A and B over 0.625, which equals 0.5 over 0.625. What's that there, please?
Four or five.
4 over 5, so 0.8. So if the probability of B is 0.8, then that must make this piece here 0.3, which makes this piece here finally 0.1. And my question is, what is the probability of B given A? That is probability of A and B over A, which is 0.5 over 0.6. What's that? 0.84?
0.83 recurrent.
Yeah. Is that not right? 5 over 6, yeah? So what confused you? Ah, okay. Okay. Continue? Yeah? Okay. 6 now. A, B. Consider two events, A and B. Note that the probability A is 0.3, A and B is 0.2, so that means that must have been 0.1. And then the probability of A given B is 0.6667. But the probability of A given B is the probability of A and B over probability of B. So that means the probability of B is the probability of A and B over 0.667, which is 0.2 over 0.6667. So what's that then? 0.2 over point, it's 2 over 2/3. Is it 0.3? No, what am I saying? It's not that.
0.299. So yeah, 0.3.
Oh, it is 0.3, okay. So if B is 0.3, that must be 0.1, which makes this 0.6. And now I can answer my question at last, which is what is the probability of not B given not A? So that's the probability of not B and not A over not A. That is 0.6 over 0.7, yeah. So that's 6/7. What's that, 0.84?
0.86.
86.
Or 857.
Okay, 857.
I'm not sure exactly.
That's okay, that's okay. Yeah. Is that right or wrong?
That's not what it says in the book.
Sarah, what's this one here? This is 6, is it? Let's see. I just wrote 0.57.
Oh,
No, but that's wrong. It should be.
8.
Oh, I just didn't type the 8. Yeah, 0.857. That's all that's happened to it. Right. And which one did you say, Sabrina, on that page?
I don't know okay about that right now because we've done so many.
Okay.
Like, can you do one from the lesson yesterday?
Let's do number 9 because that's kind of like an exam question.
On page.
Averages, 104. Yeah. Yeah. So
You said number 9?
yeah, because that's like an exam question. So you have your heights of the trees, and you know how many trees you have. What's wrong? Right. Oh yeah, step 1 be on the right page. Okay. 9. So what you need to do first is just figure out exactly what the interval is. So the first one is 0 to 20 to 24.5, because you can see there's a little bit of a gap, 24 and 25. So we need to just be clear about who's in which box. The next box starts at 24.5 and it goes up to, where am I at? 50.5. Then the next one is 50.5. What does it go up to? 75.5? Okay. What's next now? 75.5 to 100.5. And then the last one then is 100.5 to, where am I at? 199.5, is it? Yeah. Now, let's fill in the frequencies here. 5, 4, 3, 2, and 1. So for this one, you'll have to use the middle number to estimate for each box, each cell. So the middle here of 0 and 24.5 is 12.25. You just add and divide by 2. What's the middle here? 50 and 24, 75, 75, 37.5, is it? Can you confirm that? Just if we add these together, is it 37.5?
Yeah, 37.
37.5. And if you do the same for the next one, I think it's 57? No, what is it? What is it?
63.
63?
Yeah,
Point,
just 63.
just 63. Okay, and then, so 0.0 we'll say. And then the next one is 188.
Yeah.
And then the last one, 100 and...
150.
Okay. So, to get the average here, and this is the symbol for average, it's 5 times 12.25,
Good job.
the mean average. Isn't that what I said? Let's see, we'll check. Yeah, well, actually I want all of them. Mean. What? So, we'll get the mean one first. So, mean is 5 times 12.25 plus 4 times 37.5 plus 3 times 63 plus 2 times 88 plus 1 times 150
Over 50.
over 5 plus 4 plus 3 plus 2 plus 1. Okay, I'll just give you a second if you can type that in, please. Yeah, over 15, you're right.
$48.41.
48
41.
Right, the next one? Yeah, what one do we want next? What did I do? Well, it doesn't matter, I'll just do the mode next. So what's the mode here? 12.25 is the most common one. Mean, mode. Okay, the median next. So we have 15 numbers. Who's in the middle?
740.
No. 8. 8. So 5, 6, 7, 8, 9. The 8th tray is in this cell. So that's 37.5. So that's the median, that's the mode, and that's the mean there. Do I ask for anything else? Oh, the midpoint? No, I don't? No, okay. That's a common, that's a typical type of exam question.
Can we do 13 on that page? They're talking about the upper bound and unbounded bin.
Yeah? But what's confusing about 13?
That part B.
I can't hear you. What part's confusing about 13?
Part B.
Calculate the mean.
Yeah.
It's exactly what I did here. Right, no, look at me. It's exactly what I did here.
Yeah.
What would be different?
He's saying exclude the don't knows the last column.
Yeah, exclude the don't knows.
Yeah, okay, I understand that. And then when they say to help with an upper bound on the unbounded bin, that's confusing.
Yeah, the problem is with the don't knows. We were talking about that yesterday. Or not the don't knows, sorry. The more than 250,000.
Mm-hmm.
The more than 250,000. What do we use as the estimate there? Do you know?
Yeah.
That's what we did yesterday.
That's what we did yesterday, yeah. So I suggested one thing you could do is you could look at how big each of the other ones were. So if you look at them,
Find the average.
yeah, that's one thing you could do. So I said use the average length. So you should get the length of each box. So the first box, how big is it? 0.
Yeah.
The second one, how big is it? 1,000. And the next one, 9,000. And then 49,000, then 50,000. If you average those lengths, you can figure out how big the last box goes up to. Yeah, it is what we were talking about yesterday. That's actually why I did it yesterday, because I was thinking about this question. The reason I like number 13 is because it was actually a real news story in 2010. The news reported that the average savings in Ireland is 29,000, which seemed too big. It seemed too big. And that's because that was the mean average. And as we discussed yesterday, the mean average brings the average up. So I would have thought a better average to use would be the median average, because that's the middle number. If you have a list of people saving up money, the median is the person in the middle. I think this is a bit more accurate, because you can see in this table you have 30 people that have more than 250,000. Do you see that? But you have 130 people, so that's many, many times more, with 0. So you get quite a different answer if you look at the median and the mean. So I think the median was 29,000, but the mean was 29,000, but the median was 5,000. So what does that mean exactly? That means half the people have less than 5,000 and half the people have more than 5,000. So 5,000 seemed like a better number to use than the mean. It's a huge difference. The big difference between saying the average is 5,000 and the average is 29,000. Big difference. Yeah. Okay, we have time to do one more, I'd say. So
page 96.5.
96.5. Yeah. Okay, good. 96.5 now. In a school of 200 students, 80 are boys. Okay, so you can either be male or female, and you can either choose to study a second language or not. Okay. Right. Each student could choose to study a second language, and 100 students do study second language. So there's 80 boys here, and then in the language one there's 100. 40 girls do not study a second language, so that puts 40 here. So if I call this x, this is 80 minus x, and this one here is 100 minus x. And you know that there's 200 in total. So those add up to 200. So these three add up to 160, because you have 40 here. So 80 minus x plus 100 minus x equals 160. You already have the 40 outside. Cancel. 180 minus x equals 160. So x is 20. So then that is 20 here, 60 here, and 80 here. How many boys study a second language? 20. 20 is the answer, I hope. And it's fine, you do those probabilities, and then at the end you multiply 1/10 by 200, yeah?
Yeah,
That's fine. Yeah, that's fine. Absolutely, no problem at all. I just saved myself a bit of time by not bothering to divide everything by 200. Come on. Anyways, it doesn't matter. Wait, before I go, I better check the attendance. So, which group is this? Features 2. Oh yeah, here we go. Okay, so Michelle, yeah? Oh, there you are. Avir, Autumn, oh. Celine, there you go. Sophia, Mubarak, Shdira, Mohammed, Sabrina, yeah, Moza, no. Angela, yeah. Ahmed, no. Safra, no. Lucas, no. Neil, yes. Okay. Mubarak, are those noise cancelling headphones? They're not the noise cancelling ones. They're just regular ones, is it?
Yeah. You mean the ones that you just put the thing and then it shuts everything out?
Yeah.
Listening to music.
Those are good.
Yeah.
Does anyone have those?
My brother had one.
Yeah, I was going to actually email you, but since you're here,
I have you this
Yeah, I
afternoon.
saw
as
them
well.
at like, you know, Jimmy.
Yeah.
oh, I can't remember. I'll just email you. I have a little bit of feedback. So obviously, you'll get more marks when you put the Excel
The summer.
part in
I
and the
figured out how to
summer.
do
Yeah,
it.
yeah, yeah,
And
yeah.
the summer, yes.
You got the Excel in?
I think so.
Okay.
I need to actually try to send it to you in an email to make sure it doesn't get in
Okay. Well, I'll give you feedback on what you did send, though. I'll email you later. Then. Yeah. And you have something here? Yeah.
I wanted to ask if there's a way to get all this in one page or something.
Oh, there's always a way.
I tried so much yesterday and I was very frustrated and it had come for a second, then I did something.
Why not make it a 2-column page?
Is it fine?
Well, make it 2 columns for the page with the data on it. So this is what I would do, okay? This one here is fine, this one. Put this one on a new page.
Okay.
And then when you start the new page, it'll be up here.
Yeah.
Then make the page 2 column, so it'll go along here. And then when you get to E, don't type it on this page because it'll be in 1 column.
Okay.
Put E starting on a new page. Then when E starts on a new page, you can go back to 1 column.
Okay.
So in other words, just temporarily switch the page to 2 columns for the table with 100 in it.
Okay.
That would be the easiest thing I can think of then. You can just Google how to do that, like how to make 1 page 2 column in Word.
Okay.
I think that'll fix it up.
Can you just read the explanation so that we can see if it's fine?
This is all fine. It's this one needs to be expanded more.
Which one?
G there.
What would I have to do?
Oh, that'd be telling. That'd be giving you too much help. You need a verb here,
As in?
as in like, what is the verb? When something to a small n.
Oh, sorry.
Yeah.
I was doing it in a hurry.
Yeah, it's okay, it's okay.
Because I live far away, so I had to print here before I left.
Everything is fine, but just make your sentences a bit bigger. Just pad it out a bit, you know. So like here you say, which is an even worse approximation. So, you know, just stretch it out a bit. You can say like, the approximation here, which is minus 91 over 8, is further away from the true value, which is
Okay.
whatever it is. You know, like, it won't kill you to stretch it out. So like, it's fine, it's fine, it's fine, it's fine. It's just a little brief. And that's,
Well, they did say it has to be brief in the title
yeah,
page.
but I know. And I wish they didn't say that, because then the problem is students then become too brief. What they really should have said, and what they mean is, don't go on too long about nothing.
Okay.
Do you know what I mean?
Yeah.
Because sometimes students think, oh, if I write a lot, then I'll get lots of marks. I'm like, no, you can only get 1 mark because it's a 1 mark question, so don't write a paragraph. But at the same time, you know, you could make your sentence, you could have a longer sentence,
Yeah.
okay? So it's fine. If you expand these answers, in particular G is the one, F and G here, needs to be expanded a bit more, okay? If you want,
The summary is fine, other than the word adding thing.
again, it's so short. Is it, does even 100 words?
No, it's not.
Yeah, like, if it, go up to the 100 words.
Okay.
When this is expanded for small n, for example, a good approximation plane as long as the value of x is nearly 0, like when this may be possible for any value of a that is an integer. Yeah, that's true, but you need to expand it. And also, that summary and conclusion is for both. You said no.
Is it for both?
Yeah, I said this in class. So you would have lost half the marks for your summary because you only half summarised it.
Okay.
So anyways, I guess it's a good thing that I checked it now. So I'll just you only have half the summary there. All right, so you have a little bit more to be doing, but you're doing fine.
Okay, thank you.